All right. Good morning, everybody. This is the August 10th CAPN office hours. As always, this is posted to YouTube, so don't say anything you wouldn't want to be broadcast to the entire world. Not that we get a ton of viewership, but at least it's out there. And yeah, we basically have a almost non-existent agenda. So if anybody has anything they want to bring up, please add it to the actual Google Doc agenda, and we can get started.
Yeah, I would like to discuss the implementation of the kubeadmin templating. I will add it to the agenda later. So based on the suggestion from the maintainer of the kubeadmin, they do not suggest us to copy the code from the kubeadmin or using their kubeadmin as a library. But so I'm not sure what's the next step. I think right now we have 4 options. First one is we just import the kubeadmin as library. Then that will cause we will have a very complicated Go modular file, and it will be complete. I think it's not recommended by the Kubernetes community to import the whole Kubernetes module. And another solution will be based on Chris' suggestion, we can host a vendor directory, and we can just copy the kubeadmin directory into the vendor directory and just change the path of the inside the kubeadmin file. So each kubeadmin source file. That's the second options. That one is, I think it's okay because kubeadmin, the whole directory is quite self-contained. I have already tried this solution and it works. There is no problem. And I think this one is workable because in the future, if we wanted to just do, maybe they just upgrade the kubeadmin. If we wanted to upgrade our kubeadmin fork, we can just copy the directory to our vendor directory. So it's more maintainable in some case. And then the third solution will be we just copy the code from the kubeadmin repository. And I tried to do it last week. It turned out to be there are 2,000, maybe more than 2,000 lines of codes and the constants. We just want 2 functions, but they're quite nested. We keep calling other functions, and it turned out to be we are going to copy the whole repository, whole directory to our code base. And I think it's okay, it's workable, but I think it's not the best solution because we need to maintain all this source code. If they change anything, we will get breaking our side. So I don't think this one is a good solution. And then the last option is suggested by the maintainer of the kubeadmin. They suggest we can just use kubeadmin to generate the templates. It's literally just running the kubeadmin command and kubeadmin initial and generate all the templates and copy these templates into our repository. When we try to generate the control plan components, we just use the templates and to generate the components. And then the kubeadmin provider, since they are using the same templates, same mechanisms, and they can compatible with each other. So that's the 4 options. And for me, I would say my preference is the fourth one. We copy the template. We use kubeadmin to generate the templates and copy it into our repository. Just set it as a constant and then just compile it into source code. And each time we generate, just read this constant variable and to generate the components. I think this one is quite reasonable because I think each time in the future, if we wanted to announce a new version of CAPNs, we will say, okay, it's a version maybe 0.2, and we are going to compatible with Kubernetes version, blah, blah, blah. And we are just need to maintain all these templates inside our repository, then that will be okay. So my preference is the fourth option. So I want to know what's your guys' suggestion, and do you guys have any preference? Mm-hmm.
So how many times do the users need to generate a template? Is this
it's just one time. For now, it's just when we create the control plan components, we will generate the templates just for once.
Oh, let me think about it. So for the addition, if people want to customize those final YAML, they won't go through that template. They will go through our API, our patch API. Is this?
Then we can implement we can implement a function that apply a patch to the templates. I think that's okay. Yeah, we can host the base templates from the kubeadmin initial.
Yeah, because we are talking about the base template, right? Because the Kaplan, our Kaplan component CRD has a common spec, which has a patch if you want to change but we are only talking about the template read by the Kaplan component, right? So.
Right, just the template of the Kaplan API Server Control Manager and ADCP. So I think we should only allow user to change maybe just the command line, the arguments of each component. If we want user to allow user to change other configuration like network and everything, then that they may misconfigure one of the components and make things not working.
So are the templates all the things that we want to get from the kubeadmin? So do we want to get anything else from kubeadmin, or all we need are the templates? If that is the case, I think it's okay. So we shouldn't even consider include the code. We should just use that binary. If that's all.
Right. For now, I think templates is the only thing we wanted to get from the kubeadmin. Yeah, based on my observation.
How about that? Because how about that? What's that? The node controller, the virtual, whatever.
The machine controller.
Sorry, that's the machine controller. Do you want to get anything from kubeadmin for that implementation?
Chris, do you have any idea? Maybe in the future you wanted to upgrade one of the components. Do we need to get anything from the kubeadmin library? I mean, for the nested machine controller.
Technically, no, I believe it's supposed to just be the manifest, because once we get, so the end of the day, what we're trying to use kubeadm for is just purely generation of the manifest. And then when it updates to a new version, we're going to regenerate those manifests and then just reapply those to the cluster and let the new nested machines bring up the new work or the new control plane. I don't think so. I don't think there's any imperative commands that we're trying to run out of it, unless we're trying to specifically get the after deploy components in. So core DNS can get auto deployed. But I think that's just generating manifest as well and adding it and applying it to the cluster. I think that might be it. That is just the manifest. Now, so real quickly, just so I can fully clarify, and I'm so sorry, Scott, for accidentally kicking you out. I did not mean to do that. But I'm glad you're back. I was trying to remove a bot.
Zoom. I just signed out of Zoom and then logged in as a guest, so no problem.
Okay. So sorry. Next time, I think you should be able to come back into it fine. And if not, I'll figure out how to deal with this. Anyways, real quick, just go back to that. So the thought process was we use kubeadm as a binary inside the Docker image, just fork or exec the process and then generate the manifest and then load them back into the nested machine or the infrastructure provider in essence, and then be able to parse them inside our code after the files are generated. Correct? That's the thought process.
So the Docker, the kubeadmin Docker Docker container will be part of that will be deployed during the runtime, right? Is that what you want? Like, okay.
Well, then I'm trying to understand. Is that the suggestion that we would do it that way?
So my suggestion is just to get the templates, literally just the templates and assign it to a constant. And when you compile, it's just inside source code. And when you generate a component, you just read it constant. Use these templates instead of running a containers during a runtime to generate the templates. Yeah, I think it can be more, more straightforward.
Yeah, I mean, it's basically what we have right now. It's just that we'd be trying to converge ourselves with kubeadm from a spec side of things, and we'd have to re-implement everything that kubeadm and the bootstrap provider do, correct? Because like if we don't have the manifest, if we don't have kubeadm generating everything, on the fly for each cluster, we have to go re-implement how each one of those things get added. So how do you add new flags to the API server? How do you change the flags on the Cube controller manager? How do you set up different, the config files that get laid down? We have to like figure out how to set all of those things up, correct?
So if we wanted to set all those things, we have to have the kubeadmin library. Is that correct?
I think so. I mean, unless we go the route of like execing something, but I'm not advocating for it. I'm just trying to figure out how else we could do this. We could build like a job image that gets fired off. It generates a bunch of files, saves them to secrets or config maps for you, and then we load those back into the controller itself, so that we like you could in essence make the control plane. Sorry, not the control plane. The nested machine kick off a Kubernetes job that goes and runs kubeadm, generates the files, saves them back against the Cube API server, and then the controller repicks them up. The nested machine controller then repicks them up and applies those files that got generated to the cluster if we wanted to. It's just a very multi-step process then.
So okay, so yeah, I just wanted to be clarified. So the complete process will be we apply a kubeadmin control config. That's the CRD or something. CR, and then its config will including all the customized option like the arguments of the API server, everything. And then this one will be the config. We will generate templates based on this config. And your suggestion will be if we wanted to finish all this process I just mentioned, we have to have a kubeadmin running to read this config and generate the templates during the runtime. So that's the whole point why we wanted to have a running Docker container that can generate the kubeadmin templates, right? Yeah, that makes sense. Yeah, I forgot this part. Yeah.
Yeah, that's my thought process, is like the only way we're going to get upgrade strategies built in is by doing something like that. By having kubeadm constantly be the thing that we then back down to generate the manifest, to update whatever we need to then reapply to the cluster. It's a pain though that we can't get this. There's no way. Sorry, go ahead, Faye.
Yeah. So, but I would think we can do this because when we design the CapPN component CRD, we thought we can manipulate the base template by using the patch commands, which is kind of different rounds to apply what you want, right? So we're just saying that kubeadmin has its own ways to set up all the parameters for different YAML files, but essentially we have another way because our API has a patch API. We can do the same. So if we do everything through our CRD, then we just need a base YAML. So I think that's one point. We can just, but essentially that is our current implementation. We have a bunch of base YAML. Then we use a patch spec to change that base YAML. That's our current implementation, right? So there is another way. That's your suggestion is we leave everything, this customization using the kubeadm API to do the same thing. So I think the question is whether we want to go. So if we go that around, we probably shouldn't even add our patch spec in our, because everything is just the YAML that has everything that you want. You shouldn't use our API to kind of change that base YAML again.
Yeah, I think that's the good point. And yeah, I discussed with Chris before, like why we wanted to use the kubeadmin instead of just using a static template and apply the patch. So we think if I made any mistake, please correct me, Chris. So so we think if we can use kubeadmin, because we want to use the existing component called kubeadmin provider, which is included by the CAPI, also used by the default provider. Right now, default provider is just a Docker. So we wanted to reuse this kubeadmin provider to help us to manage the whole life cycle of the control plane. So that's the reason why we wanted to go with the kubeadmin. Sorry, my daughter is crying.
Yeah, I'll continue there. while Charles does that stuff. Yeah, so the idea there is basically try and get as close to alignment with CAPI core components as possible. Because if we can do that, then portability becomes even easier for anybody that's doing this. So Scott, for example, could go and say, hey, let's actually make a pod-based control plane that in theory doesn't even use VC if we didn't have to, but at the same time could use VC, but could go and say, I'm going to make a pod-based control plane and then hook up a bunch of physical hosts to this pod-based control plane. And it doesn't really matter. And it would be the same exact templates that you might use from the kubeadm, not kubeadm, the cluster API provider for AWS or GCP. It's just like the parity between all of those components. If we can get that, also the benefits of not having to build this ourselves, not having to maintain here's how you patch and here's how you maintain, and oh, we didn't allow you to control this, but kubeadm does, and people are thinking about it from that side of things.
Yeah, so I understand that part. So, but my actual confusion is, if we want to do that, how comes we only need a binary to generate a manifest? So
because it's hard to, because it's basically not recommended to import it into code. Like, because I mean, it would be great. And the hope there was that we would be able to get the manifest out of it without, manifest out of the kubeadm as a library, and then use those. So instead of having to do this like extra Docker image or include the kubeadm binary into the Docker image, instead of doing all that, be able to use Go to just generate the manifest, grab the file or grab the contents, load it back into the kube API server, and then we can kind of just run from there. Go ahead.
Yeah, so I was thinking if you want to do that way, so I'm assuming, sorry, I haven't tried, but I'm assuming kubeadmin has an API called kubeadmin upgrade. Let's say we have that API. So if we want to go that route, it seems like we want to leverage the entire upgrade workflow provided by kubeadm. So then we shouldn't even, then we probably even has a case that not only generated the manifest through kubeadmin, through the kubeadmin init, we probably even have a way to call kubeadmin upgrade directly instead of write all the codes by ourselves, right?
Yes, although I believe, and Scott, hold me honest here, or Wei, if you've worked with kubeadm under the hood, I believe what that's going to be doing is mostly just like creating a new. By the way, I apologize if you hear hammering behind me. I've still got construction going on in my house. But anyways, I'll go as fast as I can. My assumption here, and from what I've worked with it in the past, is basically this is just going to create new, or going to apply on new immutable images typically. And so kubeadm from the Kappa side of things, or the Kappa side of things, it's going to go create some new EC2 instances and run kubeadm against those with the new manifests. And the upgrade is really just coordinating that effort, which I don't think we have to do as much of from our side of things, because we just need it to generate the new manifest, and then we can mostly let Kubernetes do the upgrade itself, because we can just apply a new set of control plane hosts. Now that these control plane hosts, that just the pods that are necessary for it, once those are all up, we can then drain everything from the other API servers and just transparently move all of that to the new control plane. So yes, a little bit of that imperative command, but I think most of that is the coordination piece that we don't need to pay that much attention to.
Okay. Interesting. Okay, so you can just change, restart everything. It's interesting. Okay, so I was thinking, because they need to take out for all the, because when you upgrade, you have to restart all the components, right? You need to restart API server. You need to restart the control. I don't know, EDCD part, you probably have your own ways of upgrading the EDCD instances. Because once we do, so you know that we have kind of ordering stuff, we have kind of somebody waited this it up, then so we have this kind of ordering stuff. I thought this should be handled by kubeadm, because they need to resolve certain kind of dependency anyway. So if this part is still leave to us, we still can. So my concern is we probably still cannot just simply, let's say, change the stable sets image. It's not as easy as this.
Yeah, there's a little piece here, which is if we do this right, the long-term path is no stateful sets, and it's just pods. And so instead of having an orchestration object, you're basically just creating a couple new pods that are connected to the same service that's routing through. for etcd, yeah, you're right, there's going to be some more coordination there that we do need to build into the nested machine rollout just to make sure everything's up and running before we apply that. But for the most part, you should be able to just create 3 new API server pods with the new version of the new pod spec that gets created from kubeadm, apply that to the cluster, let those come up, configure themselves with the load balancer. Same with the controller manager at that point. Really where it gets difficult is absolutely right, the etcd implementation. Which, I mean, we haven't changed a lot of patch versions on etcd most recently with a lot of our releases, luckily. So maybe those can, like, we can check a version and say, cool, let's not touch etcd and just bounce API server and controller manager. And then we have some level of an upgrade strategy and then work on, we can always, for the first version of this, consider CapEnd based etcd always considered external, and just not do any life cycle on it for these first set of releases. But I guess that kind of leaves us still back where we were coming from with, is like, how do we do this? How can we do this if we shouldn't be vendoring, right, Charles?
Yeah, correct.
I think it's okay that now we need to make a decision that we should change our spec a little bit. So we shouldn't allow the change the, component YAML through our API. Yeah,
I think that was part of the design that we have a pull request still open for, which is basically the long-term approach for this is get rid of the nested API server, controller manager, and etcd CRs. And then we just have a nested cluster CR, and we don't even have a nested control plane CR. So we get rid of four of a whole code base in a whole directory of the CapEnd repo right now. That entire control plane directory would go away, and we would just be leveraging kubeadm as the control plane provider.
I see.
So then, then it just becomes the nested cluster, which is not really meant to be updated much. That's basically just supposed to be a static object.
Then we implement our own machine controller, basically.
Exactly. And that's where all the logic gets moved into for provisioning a host or provisioning a control plane with whatever number of pods it needs, and so on and so forth.
Then we have a component upgrade dependency, which is the kubeadmin. Right. Okay.
Which is a good thing. I mean, that's again, that's parity with everything else, because that's why we have V1 Alpha 4 and why there's upgrade strategies or why there's constant churn within the CAPI world, because it's following those releases. So it makes it a little bit easier for us to follow along with them.
I think it's okay. I'm okay with it. It's because our way is kind of diverging, because we're trying to have another way to manipulate the spec. So if there is already a way and people love it, so why not just reuse it? If binary seems okay. So what is the interface for kubeadmin? So they have their own CRD. How do you know that, or Chris, do you know that?
No, they do not. They right now only have the command line. So you have to run a command line and generate all these things.
Well, they do have from the CAPI side of things, there is a CR. There's the kubeadm control plane, control plane config, or whatever the actual CR is called.
Do you mind share the CR definitions? I want to take a look at that CR. So,
yeah, there's 2 CRs. There's the kubeadm control plane, which is the control plane object, and then there's kubeadm config templates, which generate kubeadm configs, which is how worker nodes join a kubeadm cluster. So there's the kubeadm control plane has embedded within it the spec of a kubeadm config template. Basically, it's just a nested CR within a CR. And then there's the kubeadm config template, which is how you configure machine deployments or worker nodes, basically.
I see. Okay, let me see. Yeah, I want to take a look at how flexible it is.
Yeah, I dropped both links in there, the control plane and the bootstrap provider for you.
I thought I see it.
If you've ever worked with Kind, you can basically, so what's really cool here is we're getting closer to being able to converge with what almost every single tool is using these days. So like if you look at that bootstrap provider, you'll see an init configuration, which has how bootstrap tokens are set up, how the node registration is, where the local API endpoint is, all the configs that you typically have, and down into like the cluster configuration, you basically have all of those pieces that you would use out of kind to do patching against. You have those now accessible to us, which should then, not should, which then in essence mutate the pod specs that are generated on disk for us typically. And not just like that on disk part is where we get kind of screwed.
I see.
I think, but but in our implementation, maybe we should just focus on the kubeadmin config, the CR, because we are only need to use it. The rest of the part will be completed by the kubeadmin provider controller. And based on what Chris just described, I think, then we should thinking about using a Docker container to running a kubeadmin to generate the templates during runtime. I think
So-
it's possible. We can have a sidecar container just running with the machine controller and keep generating the templates when we want it.
Generate them in that's an interesting idea. You could do it that way. You could have it inside the infrastructure provider as a sidecar that's just kubeadm. You call
Correct.
out to that. You could then generate the manifest on some in the file system, and then
Correct. That's what I think.
Yeah.
Sounds very interesting.
It definitely could be done that way. Another way to think about it as well, because we need to be, I don't know if anybody would care, or I don't want to bring this up with them yet, but like there's a SIG security policy thing that's going on right now with Kappa or CAPI to basically go into evaluations of CAPI security. And I'm curious if there would be any, if anybody would bat an eyelash at doing it that way, because at that point, what would be interesting is we need to the nested machine, we need to then load up the CAs for every single cluster into it so that we can then use because the other piece that kubeadm is going to do is generate the client certs that we currently do manually, or we currently use like Go to generate and then apply as secrets. We'd have to do that through kubeadm, through the machine controller, load those in so that then all the manifests that are necessary for that pod to get scheduled get generated, and then we take all of those files and apply them back into the cluster. There might be some concerns there if we're then loading CAs from every single cluster into that single nested machine. And it might be something where we want to think about, we don't have to immediately, but just to keep this in mind in terms of how it's built, this might be something that we have to kick off from the nested machine. We create a new job, a Kubernetes job or something like that, or just a pod that gets booted up, pulls down all of the resources it needs, generates everything, applies it back into the Kube API server, and then shuts itself down and starts over for every single control plane host. Because if you think about it, we need to generate one for every the components for every single piece. Scott, you're going to jump in there.
Yeah, that's if you want to do the certificates through kubeadm, because the kubeadm control plane does support also bringing your own certs if you pre-generate them from the current implementation you have. You could just pre-create the secrets, because kubeadm control plane will just look for the certificates by name, and if they don't exist, we'll create them. So that's another option if it's a security risk of doing all the CAs that way. It does make it so you need to maintain that certificate generation code, but it does make it easier in terms of security of not needing to mount into a single place.
Yeah, I wonder what because kubeadm is also going to be generating the kube configs that are going to be used for accessing everything.
Yes.
And I wonder if that would be because they're going to never mind. It doesn't matter because they typically just do a like certificate authority path, not the actual certificate authority data base 64 encoded. So we might not have to worry about that. Sorry, I'm not giving full context. What I was thinking there was if we were to do that and basically say, okay, we have certificate generation outside of this and we're not going to use kubeadm to do that, how does kubeadm itself still generate everything it needs to without being able to load up those CAs? But I guess it probably doesn't matter because it would just use it based on a local file path in the kubeadm or in the kube config generation. And then that would get saved to the cluster.
Yeah. I got a question. I think we only need to generate a template, the manifest, right? We don't need to generate the certificate or CA.
CAs, I think we get out of KubeADM. So I think that one's fine. It's more the client certs that we need to load the CAs so that we can generate those.
Yeah, but
Or
for
maybe
now,
not.
our implementation is using the certificate manager, right? To generate all these PKI things. I think we can keep doing this way. We just get a template from the kubeadmin, but we replace the pass to point to a secret or something and do the mount, like mount a secret into the API server and change the pass. That's what I did right now, even though I'm using the kubeadmin library to generate templates, but I can still manipulate the CA certificate and key, everything. Just change the arguments inside the like Kube API server. I'm not
Gotcha.
sure if
Okay.
I explained.
No, that
right.
makes sense.
Yeah.
That makes sense. Yeah, I think that's kind of what Scott was pointing out as well, because that's if we do generation of certificates outside of the scope of it, we don't need to worry about it.
So will kubeadmin be enhanced with security with this part of code or no? So that's the only reason. So if they have to do something more fancy or more advanced, maybe you can leverage it. So that's I'm curious. Otherwise, I was thinking, because all the, certification management may be out of the loop. Many people just have their own ways to manage overall certificate. They probably don't even want there's the controller, like, control plane controller to take care of all this kind of thing.
Yeah, I can say from other providers and whatnot, and what we're seeing is that a lot of people are generating their own certificates even before KubeADM control plane, because they want it signed by their own organization, CA or things like that. I mean, KubeADM control plane will use the default cluster issuer that is self-signed certs. So typically what we'll see is, a lot of times people will just create the certificates themselves. Or if it's just for dev test environments, they'll use self-signed. It doesn't really matter in that type of case. And then they let KubeADM control plane generate it. But either way, KubeADM reacts the same way.
Cool. That seems reasonable then. I mean, that's definitely a path forward to begin with. Yeah, even though we don't need to deal with it too much.
No, I think it would be awesome to get CAPN as a control plane provider with like CAPV or Kappa as the machine provider also, and not necessarily just VC, because there are a lot of use cases where people don't want necessarily just the extra machines for control planes in clusters, and especially looking at like the CAPV perspective where you're limited in your resources, or maybe I guess public cloud if you're limited in money. In both of those cases, you don't need to spin up entire machines for just the control plane, and that'll be a minimum of 3 for anything that matters. So definitely that would be huge, and I think would gain a lot of adoption of CAPN for the control plane, at least, provider, if that integration ends up happening by moving to KubeADM.
Yeah. That's good to hear. I'm glad for the validation of that, because like that's kind of the whole point of it is like, all right, we can get more adoption out of this if we do this, which means we can get more contributors, which means we can get more support, which means we can do so many more things with this if we go down that path. So I'm glad to hear that. Thank you for validating that, because that's been somewhat of an assumption that it would help. So
I know definitely that I know a few people that would definitely be very interested in that functionality, because I've gotten that pushback on CAPV many times, that they need an extra 3 VMs for every cluster just when they need 2 worker nodes.
Sure. So, okay. So from your side of things, Scott, just a opinion or I mean, from your experiences, would you, from an implementation side of things, do you see any concerns with anything that's been said in terms of either like using a sidecar container and generating all the manifest in there, just forking execing? Do you see that would cause that people would, I don't know, be concerned by that, or do you think that would be an acceptable way of doing it, since it doesn't seem like the maintainers want us to vendor this and want us to import it?
Right. I think that it is currently probably the best way to do it. There is talks about making KubeADM into a library and exposing public APIs, and that just doesn't exist yet. So I think that when that happens, better to
We
move
can move
away
to
from this, but I don't think that this is a blocker from, the user's perspective, especially if CAs are done externally so that you don't need to mount all of the certificates from all of the clusters into a single place. I think that would definitely, pass.
Okay.
The use that I've seen. The one interesting thing will be updates and how upgrades will work. And I think there's probably a reason that there are no in-place cluster API providers today for in-place upgrades, and everything is done by create a new node, join it in. Once etcd is balanced, remove a node, wait for there's a whole cycle going on there. And that'll be interesting to see how that works here. etcd is the main issue. As a stateful set for an API server should be fine.
Yeah. Do you see from the etcd side of things? I imagine people aren't going to be too upset if we just call it out as being this is a first step. But if we call it out as if we basically say first step is we treat etcd as external for right now, and then we move towards like how we support that later, just so we can get some quick wins in here and get this moving forward. Being able to go forward and say etcd is considered external. We just go about the cluster bring up for right now and upgrade strategy, and then we start to operationalize what etcd in this world looks like after the fact.
Yeah, I think it makes sense. I think also there's work going on with external etcd right now in cluster API, which will be in V1 Alpha 5. So I think that once it becomes its own object, its own controller, which is being built with etcd ADM as one of the implementations, but is meant to be open to any implementation of etcd, that may open up other avenues for how to do the etcd correctly. I mean, etcd ADM just is merging now static pod based etcd ADM instead of binary based as well. So that may be able to help once etcd is removed from KCP, possibly into an external etcd provider. That may make it easier here. The one question is how you deal with the version of etcd. If someone were, for example, to deploy a 121 version of Kubernetes and now upgrades to 122, where there is a bump in etcd. So there would have to be a base version that you would support, meaning you can support up to 122, or you could support 122 and up, but it's a bump in the etcd version there that's required, as far as I know, to 122. So that's going to be the only issue that I can see where an upgrade is necessary. Usually Kubernetes doesn't command it, but now they do with 122.
Interesting. Yeah, that's good for us to keep track of and make sure we're planning for.
Yeah, just to be clear, so we are just saying that, okay, we still have, default behavior for deploying a etcd, for example, deploying a in-memory etcd, but we just don't provide upgrade strategy for that. Upgrade you have to be done by yourself. Is this what you're saying? So
basically the first version of it, yeah.
Okay.
So we'd at least, I mean, it would be the exact same thing as it is right now, where it's like, we don't really support upgrades, but we have a plan for how we want to do it. And now this is just saying, okay, now we have a plan for upgrading of control planes, but we're going to punt on upgrading etcd until we have a full strategy defined, which I think
that makes sense because
we're just making a roadmap in essence.
No, I mean, for our upstream demo perspective with the in-memory etcd, we shouldn't upgrade it because you lose everything once you upgrade it. So then you cannot demo anything. So that's how we have to do in upstream right now.
Yeah.
Right. I think the interesting thing would be, with it is the in-memory, but it's possible maybe to deal with some of the hooks in a stateful set within a rolling update of a stateful set, to wait possibly until an etcd member has synced into the cluster. If you were to do a rolling update and it replaced one of the pods, maybe through readiness or liveness probes, it's possible to wait until etcd is synced into the cluster, so you actually wouldn't lose anything in an upgrade. But that would be a whole interesting thing to look into, but would probably be complex.
Yeah, that's exactly the external controllers work, which we don't want to do because there are so many ways to do that. Right.
That's why I think etcd ADM, once it supports static pods, may be an interesting way of doing that, and can use PVCs also and not be in memory necessarily. So that may be interesting as well in V1 Alpha 5 once that's, another thing you get out of the box from core cluster API and don't need to write yourselves.
Yeah,
Cool.
another thing, just one more thing is, because if Kubernetes is running the imperative commands, I'm not sure if that, if we can put that in a sidecar, because supposedly sidecar should run a service, or if the sidecar itself is controller, you can run a sidecar. I'm not sure you can run imperative command to sidecar because the file system may not be, unless you config the shared is exactly amount space to see rows library. So my feeling is you probably have to combine these two binary into one container. That's my feeling.
Yeah, maybe we can have something like a gRPC, and you just call it gRPC, and you get into the sidecar and execute the kubeadmin initial.
Yeah, you can
and generate a file stored into the file system.
You can do that, but the question is, do you want to do that for just? I mean, you can do a simpler way, just combine the binary. I mean, when we build our binary, you include another binary. So
yeah, that's probably not a blocker for us at the end of the day, and whether it's a sidecar or all compiled into the same thing.
Yeah,
because first version can absolutely be just compiled into it. I mean, just app get installed in there in the Docker image, and we're just all fine.
Yeah, because whichever you do, you run a server for that is still non-standard. Nobody else do that. Just you do that. So maybe because I think for the long term. So it seems like we should get rid of this Kubernetes binary, because I suppose they are going to use POS as the library.
Hopefully,
that should be the direction. If many people want to do this way, right? Nobody should suggest just include a binary. I mean, we can do that. Many companies doesn't even allow to run outside the binary.
Yeah, it'll be an intermediary while we try to do that. I think at that point is if we get this moving forward, potentially this is an effort where we can talk with the rest of the groups that have been contributing to CapN and VC right now, and say like, hey, we've got some bigger efforts now that are going on that are extended beyond CapN. Are folks interested in helping us to help the rest of the community to externalize and make kubeadm a library? I'm sure that's an effort that people are it's just really understaffed and probably relatively hard to get folks to do it. But if we have use cases for pushing it, then people will probably help lean in to make that effort go faster.
I can say the one thing that is going to be interesting with kubeadm, at least in the way that it currently works in Cluster API, kubeadm is relatively coupled to Kubernetes versions within KCP. Especially. And it expects basically the kubeadm control plane CR hides away the complexities of the kubeadm config YAML that you need. kubeadm has its own API versions as well. One was just removed in 122, a new one was added. They have 1, 2, and 3 for their API versions. And basically, between different versions of Kubernetes, kubeadm control plane creates the config in a different API version. So they expect that image builder, which is used to build the templates for machines in Cluster API, bakes in the correct version of kubeadm to make sure that it has the right API versions. So for example, if you were to use the 122 one, you won't be able to use anything, I believe, lower than 117 of Kubernetes, because that I think is when the support for the version 2 of the API was added. So currently a version 2 and version 3 of the API, I think that's from V117 or 18 and up, which is fine to support, I think. I mean, that's what Kubernetes supports, more than what Kubernetes currently supports. But there is going to be a coupling there that will have to be dealt with at some point, how to deal with it, which is the only reason it may make sense to deploy along with the pods, a kubeadm pod separate and not do it in the controller and almost exec out to a pod like you have the API server, etcd, all of that, to create a separate entity per cluster, because then you can actually match that per cluster. You know that it's correlated to the correct version of Kubernetes that the user is requesting for that cluster.
Does KubeADM just follow the same like version skew rules? So like we're going to support n+1 on both sides.
Yes.
Okay.
Yes, I believe so.
So I guess basically, I mean,
But it's
potentially
not
that
just
also
what
could come down.
KubeADM supports. It's not just what KubeADM supports. It's how KubeADM control plane creates the manifests based off of a version for KubeADM. So like it's still
Oh.
using the V2 APIs. It's not using the V3 API even for 122. So like they have the conversion for V1 and V2. They don't have V3 yet. The V3 I'm guessing will come in. But so that's one of the issues. That's one of the benefits with the way that KCP was created, with the thinking that KubeADM is running on the machine, the binary is running on each machine, is that the user experience doesn't change when an API version changes from KubeADM. That's beneficial for a regular provider. For CapN, it becomes more difficult because you are hosting KubeADM now. That's now your responsibility, which isn't the responsibility of other providers, because it exists in each of the cluster's images itself. Gotcha.
Okay, that makes much more sense. Thanks for evaluating that farther. So your suggestion there is, or your thought process there is, if we do this external to the nested machine pod, basically the nested machine controller, we have externalized where it generates the manifest. That'll give us the ability to basically say, we're going to, we get a manifest that says it's supposed to be a 117 cluster, which means it needs, these aren't going to be real values, but like we're going to generate a 117 cluster, which means we actually need to use this version of KubeADM, which means go create a new Docker image that has this version of KubeADM in it, generate all the manifest, add the, have something that then uploads us back as config maps and secrets. And then we can then go back to the controller, to the nested machine controller, and start doing work based on the generated manifests, externalized from the cluster, or externalized from the control, the machine controller. Yeah.
Basically, the KubeADM image that you would create would be for each major version of Kubernetes. So 117, 118, 119, anything you would support, you would have a image of, and then that could be pulled at runtime when you create the manifests, just like you are today creating the static pod or pod manifests. You would create the manifest with the relevant image of KubeADM that you've generated. And when you want to support 123 when it comes out, you'll create a new pod, you'll create a new image basically to host the KubeADM of that version.
Okay, that seems reasonable. I mean, it's not
it
sounds like a lot of work. Yeah, it sounds like a lot of work, but it doesn't seem like it's too crazy. Like as long as we have a single binary that goes along with KubeADM to generate, to like orchestrate that basically is the entry point that calls everything, that fires off all of the scripts and does all of the uploading back in as secrets for the resource, for the control plane components that it's generating. And that seems relatively reasonable, as long as that binary can be pretty streamlined between all of the KubeADM bits or KubeADM versions. So yeah, okay, I see where you're coming from.
Yeah, I think that, again, the other way is easier to implement, but will cause issues down the road when you deal with upgrades. So going down this approach now will make upgrades in the future easier of clusters. Going down the other approach is a quick win, but may require very likely re-architecting the way that this works completely when there is the actual support for upgrading of clusters between versions.
So Charles, does that make sense? What we kind of have to do there? At least while you're building this, it seems like you can in essence build a secondary component that's orchestrating the KubeADM bits and doing all of the uploading. You could build this in tree in the same exact Docker image for now, but as long as it's something that we can pull out later and make it so that it can connect to N versions of KubeADM, and those are just new images that we supply, then that probably
yeah.
Is this
Yeah,
possible that-
that makes sense. Yeah.
how big the binary is? Is it possible just we just include every binary for the past versions?
I mean, yeah, that would probably make sense. It's probably not that big. Because it's just then we
It's
just
not
have
big,
the infrastructure infrastructure version. It's just
Yeah.
how do you then add
I would suggest
multiple versions of kubedm to it?
I would just suggest just keep updating with the kubedm for the version that we support. We at most I think we will just copy 5 binaries, and our controller then has a way to create versions for the past 5 versions. I mean, I suppose that should be enough.
Yeah, I think that's okay. Yeah, kubedm. I think the binary is small. I generate once. It's not large. Yeah. So I think next step will be I will try to put a kubedm binary into the controller, our current NCP controller image, and I will call the kubedm binary inside the controller and generate the file and store it into the file system, and then later use the manifest.
Yeah.
Right. And in the future we can discuss what's the next step. But for next related to the PR or the issue I submit, I will do it on this way. Is that okay?
I think that's a good idea.
Okay, so I will go back and change because I need to revise the proposal. The Kaplan proposal is right now still open inside the PR, and then I will wrap up the implementation. Yeah. What do you think? What do you guys think?
Cool.
Okay.
Yeah, I love this. Thank you so much for doing all this work. This is fantastic. And thanks everybody for all the conversation about this. I think this is going to be a
Okay.
nice path forward. Cool.
Great.
Do we have anything else we want to
think
add to
that's
the
all.
agenda in the last 4 minutes or 6 minutes?
That's all from my side.
Cool. Faye, you and I need to get together at some point as well to talk about what we're going to do for KubeCon.
Is it virtual? Have we confirmed that?
I have no idea how this is going to go.
Yeah,
I got
yeah.
go ahead.
Yeah, people may not know our paper about the support multiple supercluster and do the scheduling in a namespace quota base that is accepted by the KubeCon.
So we'll be talking about that in theory in LA or in theory virtual somehow.
Currently it's going to be both masks only with vaccination passports, basically is the current thing, but other conferences have just been canceled that are a week before that. So who knows? VMware just canceled their VMworld physical conference and moved completely virtual. Who knows what's going to happen here with KubeCon?
And looking at charts in LA, it doesn't look good.
Yeah. We'll see.
So we'll be doing let's be honest, we'll probably end up doing virtual, but it'll be a fun talk. I'm excited to put that together and do that talk with you. So cool, folks. All right, I'm gonna call the recording, and you all have a wonderful rest of your week, and I'll see you next week. Again, posted to YouTube, so I'll drop a link into the Slack channel and into the agenda after that's all uploaded.
Thanks, everyone.
All right, see ya.